Okay, so now I'd like to take a little bit of time to do a little video about using LoggerPro. Now on a test, most likely the file will be sitting here on the desktop, and to start LoggerPro all you need to do is click on it and it will start right up. Otherwise, if that's not the case, you would come over here, you would start LoggerPro from the desktop. There'll be just a program icon, and you would click on File, Open, and go looking through for the particular file that you're interested in. But this is the file we're interested in. Now, some of the things you're going to want to be able to do on a test are curve fit, average, and integrate. So for curve fit, one of the good ways that we could get the acceleration for one of these three runs of the cart, 1, 2, or latest, which is 3, is to fit a linear line to the velocity versus time graph. So to do that, we look for a part that is nice and linear. No sense fitting a linear line to a part that isn't linear. So I highlight this whole region that is nearly linear, and I click here, which is the curve fit. I click on it. Yes, I want to use run 1. And I say I want to fit it with a linear. I click try fit. I see up here that the line matches the data very nicely, and here's the slope and the y-intercept. So I click OK. So that tells me a slope of negative 0.08239, and it's meters per second, so that's meters per second squared. See, meters per second. So that's a pretty reasonable value for the velocity. I could also find the acceleration by averaging the acceleration versus time over the same region. So here I'm going to highlight the same exact region, at least as close as I can. And for averages, I'm going to hit statistics. Again, I want it to be of run 1. And there you can see the minimum was negative 11.53, maximum negative 0.0611. So those are off a bit. But if I take the average, the mean is negative 0.084, and the median negative 0.079. Both of those are in the same neighborhood as the slope that we got before. However, I'm still of the opinion that your best reading for an acceleration is the slope of the velocity. Alright. Then for this problem, we also wanted to know the average force, and we would want that over the same range too. So we would highlight the range, the force, hit statistics, run 1. Okay. And that gives me a value of negative 0.3532. Excuse me, no. The mean is what I want. Negative 0.3336. Now, typically, 4 significant figures is probably a bit much. The values vary quite a bit over that. So I'm probably only going to take 3 of those, and even that's probably pushing it. So that's how we curve fit and how we take averages. If I wanted to curve fit more, I could look here and say, well, I want to know what's going on with this one. I don't want to go as far to the right because it doesn't stay linear as long there. Curve fit velocity 2. Also linear, so I try fit. Okay. And I can curve fit. This one I want to stay even further to the left. That's the latest. Curve fit the latest. Also linear, try fit. Looks beautiful. Okay. So, and I'm going to put these up try and place them somewhere so that I can read the values off later. So there's run 1, run 2, latest. I want to get my force averages over a similar range of time. So I want to try and get a sense. Let me move this so I can see what the time ranges are. Alright, so it looks like I'm running from about here to about there. Okay. Statistics on run 2. And then I want to go from just a little bit earlier to only about there. Statistics on the latest. Okay. And now let's arrange them left to right so I can... I'm just grabbing them and dragging them like you would with a lot of Windows programs right now.